Go ahead and get started. So what I'm going to talk about today, I've got two talks this weekend. This is the first talk where I want to talk about building a minimal host for Docker containers. Tomorrow I'm going to talk about the package problem, which is the next level of this talk. It's sort of like a two-parter. So tomorrow is the sequel. Tomorrow will be the sort of Enterprise Strikes Back to the Star Wars here. Hopefully not one of the prequels. So one of the things I like to encourage folks to do is to use social media. So if you have thoughts about the presentation while I'm going through it, I'm JZB. Project Atomic is at Project Atomic because all the short names were taken. And so this is hashtag #InfraNext. If you have anything you want to shout out on Twitter, and I'm sure you all are tweeting about SCaLE Linux Expo already, right? So show the love. Let's see if we can make SCaLE trend on Twitter this weekend. All right, so real quick, who is this person? Why are they talking to me? My name is Joe Brockmeier. I work for Red Hat. I work pretty much full-time on Project Atomic, which is a large portion of this talk, what I'm going to be discussing. And before that, you may remember me from such jobs as OpenSUSE Community Manager, and I am also a recovering tech journalist. So I've been around the Linux community for a long time, been coming to SCaLE since 2006. So that's who I am and why I'm talking about this topic. So what I'm going to go through real quickly, we have a 45-minute talk. I think talks at conferences are sort of like NASCAR. I'm going to attempt to do a demo during this, and people don't really come to see the talk, they come to see the crash. But if I'm very lucky, the live demo will go off without a hitch or without too many flames. But what I want to do is talk about what Project Atomic is. I want to talk about its history, pulling the pieces together, the anatomy of a host, status and future, and basically the concepts that we're putting into having a Docker or a container host, really. I want to talk a little bit about that. I'm assuming everybody here has heard of Docker and Linux containers at this point. Anybody in the room who's like, I've never heard of containers? Nobody? Okay, good. So what is Project Atomic? It is a weird project, and I say that affectionately. But so in the past, I've worked on open source projects like CloudStack or OpenSUSE, where you can very easily say, boom, this is what we produce. Atomic is a little bit different because we are actually trying to produce tools and patterns for creating what we call an atomic host. And I'll get into that a little bit more. But we're trying to do it for 3 distributions. We're trying to do it for RHEL, Fedora, and CentOS rather than creating a new distribution. So Red Hat produces RHEL, and we sponsor work on Fedora, and we now sponsor work on CentOS. We didn't really need a 4th Linux distribution to run containers with. So we instead decided we wanted to come up with a way to use the same bits, but to do just containers with those bits. Project Atomic is also our community infrastructure, so it's all the mailing lists and forums and all that good stuff. And it encompasses a lot of things like RPM-OS tree, which I'm going to talk about a lot. Cockpit. How many folks have heard of Cockpit? A couple of folks, good. I'll try to give a short demo of that as well. We've also gotten into, I need to get Gear D off of this slide. It's actually pretty much gone. But talk a little bit about orchestration, talk about Docker and some of the other stuff that we want to put in there. So why are we working on Project Atomic? Why is this important? You know, you can run Docker containers on RHEL. You can run Docker containers on Fedora and CentOS. Why do we need, a special host for them, and why do we care about running containers? I'll talk a lot more about this tomorrow, but the, short version, traditional packaging is pretty limited, right? Actually shipping packages and shipping applications via RPM or Debian packages is sort of a limited way to do those things. Containers provide a lot of advantages. But if you're going to run things in containers, why worry about the rest of the packaging foo? You just want a host that runs the containers, and you don't want to really worry about the host that much. A traditional OS like RHEL or, CentOS is kind of overkill for running containers if that's what you're going to do on that host. You don't need everything that comes with a typical install of CentOS or RHEL. And you need some things that you don't necessarily need on a host if you want to do just containers. You need the orchestration bits. You need Kubernetes. You need Flannel and etcd and things like that. And also, one of the things we're going to be working on this year extensively with Project Atomic is packaging guidelines for containers, because we're seeing some truly, one of the first talks I gave about Project Atomic and containers and explaining, why Docker is great to an audience that was still pretty new to it, they're like, but can't you do like really terrible packaging things in a container? Like, can't you ship terrible stuff in a container? And the answer is yes. Yes, you can. You can even do worse things than RPM. So we need a little bit of help defining the best way to package and run applications. So what am I going to provide with an Atomic host? Streamlined host running for Docker containers. We're going to build the host from a trusted distribution. So if you're already running RHEL in your data center, you're already going to know how to work with Atomic. Okay? If you're running CentOS or you're running Fedora, you're already going to know more or less how to manage Atomic, modulo the bits, that are specific to containers. And you're also going to know that the kernel package, if it's certified when you're talking about RHEL, if it's certified for your hardware when it's just RHEL, then RHEL Atomic will also, work on your hardware. And those things are kind of important to folks who have done a lot of work making sure that those things work in their environment. And of course, we're going to be providing orchestration for running these things at scale. Anybody participating? We're going to do a Fedora activity day on Sunday. How many folks participate in or follow the Fedora Cloud Working Group? Anybody in the room? Just one or two people? Anybody interested in the future of cloud and or interested in Fedora? Please feel free to turn up on Sunday, and we'll be doing an activity day to talk about what's going into Fedora 22 and 23. Pretty much at this point, Fedora 23, because we've already had to define what's going into 22. Also want to talk about what the hosts do not provide. And the reason I bring up the Fedora Cloud Working Group with this is we get a lot of people who are like, well, I've always done X, Y, or Z on Fedora, and I expect the Fedora host to have my favorite tool, whatever that tool may be, whether it's Git, whether it's, tmux or Screen, whether, whatever it is. And the whole point is not to have anything you don't need on the host to put it in a container. So the first thing that you're going to hear whenever you come back and this would be great if you just add this 80 meg package. The answer is going to be no, put it in a container. And if it doesn't work well in a container, then we need to figure out why it doesn't work well in a container. And there are very few things that you cannot put in a container. Right now it may be very hacky, and it may be, is Jim Perrin in the room? No, yeah. He may or may not bust out a little hack that he had running some really evil stuff in a container with wine. I love the murmur that goes through the room. It's just like, ugh. It's like Pet Cemetery or something, it just comes back wrong. But anyway, so the whole point is the official images are minimal. Why does it matter that they're minimal? On my desktop, it doesn't matter if an image is 300 megs or a gig, it really doesn't matter. It matters when you're running these things at scale and you're passing thousands of them across your network. When you're spinning up hundreds or thousands of systems, okay? The whole idea of having an immutable host is that you don't do updates to the system, and we'll talk about how this is going to work with Atomic. The whole idea is that whenever you have an update, it just goes out as a new image, which starts to get really insane, and you start to worry about passing 1 gigabyte images across the network when you're doing hundreds of them versus, 300 megs. So, any questions so far? I'll try to leave some time at the end for questions, comments, compliments, that sort of thing. Real quick, I want to go through the history of this because we're pulling a lot of pieces together, but I think it's important to acknowledge with all the hype about Docker and everything, and some of these things have been around for a long time that predate Docker. For example, I'm going to demonstrate RPM OS tree. This was initially developed for GNOME Continuous. Does anybody remember that? Has anybody ever tried to compile GNOME to test something? It's not fun. I've done it when I was writing for LWN, for example. I would occasionally try to do, they would want to look at GNOME before it was released, which meant actually compiling it from scratch. And I have the scars from doing that because you have, and we get back to, this is all kind of circular, we get back to why people like containers, because you get into the whole, well, it worked on my workstation thing. So OS tree was originally GNOME Continuous so that GNOME developers could just pull down the latest build of GNOME and work on it without having to worry about compiling it themselves. The whole idea was to have a system that quickly compiled GNOME OS that people could pull down and run and do their development work without having to worry about compiling the latest GNOME snapshot. RPM OS tree came a little bit later, and all of this stuff was well ahead of Docker. Okay, this stuff was being developed several years ago. I don't remember the exact date. I probably should. But anyway, and Colin Walters is an interesting person to watch work. He has been doing some stellar stuff on RPM OS tree since we started doing Project Atomic. The guy has been phenomenal at pushing out updates and taking fixes, and is really a great example of somebody in open source to watch in terms of the way he manages his community and responds to people very quickly. So RPM, one of the things, I've been doing this Linux thing for a long time. I discovered Linux in 1996 and, did my share of compiling things from source, and started on Slackware. And eventually went over to Debian and then RPM-based systems. And, when we started having all this wonderful dependency resolving stuff like Zypper and Yum and everything, thought, wow, this is great. But there's one problem with RPM, well, there may be more than one, but I'm going to admit to one. There is one problem, and it goes one way. So when you do an update and you install a new package and it breaks something, RPM doesn't really have a great concept of how to reverse the stream, okay? Yes, you can do it, but it's usually painful. Updates are very difficult to roll back. How many people have been on the road and updated their laptop and had something break, which breaks network connectivity? Fun, isn't it? There's not a good way to just recover from that, okay? RPM OS tree is basically like a Git for operating systems, so it has an easy rollback function. So you break something, you can easily roll it back. So it takes the RPMs that you would normally build an image out of and creates a tree similar to a Git, Git repository. It is not a package manager, but it fills some of the deployment pieces. But if you are if you're somebody who's been packaging RPMs for a while, none of that knowledge is lost. You still put your stuff into RPMs and then produce the tree. And you still produce RPMs for all the other stuff that you're going to do, okay? Cockpit is another tool that started life kind of around Fedora. It's a server manager for administering systems via browser. It does not interfere with your normal web tools or your normal admin tools. One of the things I've seen over the years is there are a lot of great ideas about administering Linux systems, but once you start embracing them, then you can no longer just drop in and say edit your etc/foo. You now are subsumed into using your new administration tool, or it will go back and break things that you've done. I remember Yast doing that a lot, for example. If you decided, I want to edit this, Yast will come back along and go, oh, no, you don't. We're going to go right back to the way I had it, That may not be true anymore. I have not used Yast in a number of years, but it's designed to be multi-server, and I'm going to show a quick demo of that. Docker, I think we can skip over pretty quickly. The one thing I wanted to stress was just that, Docker has done some great things for Linux containers, but it's neither a new concept. It's not an original concept by any stretch. Containers have been around for many, many years. Linux containers have been around for many, many, many years. What Docker has done, however, has really refined the concept to make it application-centric, to make it easier to deploy. Like deploying Linux containers with LXC was not a piece of cake. Deploying Docker stuff is a piece of cake. It supports versioning, it's reusable. I happen to really, enjoy working with stuff in a container. As long as I remember to commit my work frequently, I can, go back to a point in time before I break things. I can choose to automate things using Docker files, or I can do them interactively. There are a lot of great things about working with these kind of containers. Orchestration stuff, if you had been in here earlier, Jason Brooks did a talk about using Kubernetes. And I guess that will show up online. If you weren't in here, you can check out his slides. But this is an old slide. I apologize. I thought I had updated this. We are not using GearD anymore. That shouldn't even be referenced anymore. We're using Kubernetes pretty much exclusively. And the Mesos stuff that we were originally going to be doing doesn't look like is going to happen. So it is mostly pretty much everything we're doing right now with Atomic is Flannel and for the networking bits and Kubernetes for the orchestration bits. So I want to talk real quickly about how we're doing the work. This is one of the interesting things. So to get everything into Fedora, we're working through the cloud work group. And again, this is an old slide I thought I had updated. I think I just pulled up the wrong version of these slides. I apologize for that. But basically, Fedora 21 is already out. We have an Atomic host with that. We are still working on a couple of pieces to improve mirroring and everything. And in Fedora 22, we expect to have a Vagrant box and a bare metal installer for Atomic. So how many folks use Vagrant in their day-to-day stuff? Quite a few. Okay. We hope to have a Vagrant box out soon. How do people feel about the whole Vagrant Cloud becoming Ajax or something like that? They've basically switched to a freemium model for Vagrant Cloud. Has anybody paid any attention to this? Yeah, they're starting to want to charge money for hosting images and things like that. So it should be interesting to see how that goes. On the flip side, we're also doing work in CentOS 7, and these move a little bit differently. And again, you can kind of ignore the slide for the most part because this is a little bit old. But basically, so Fedora has a release cadence of every 6 months. Now, you can check out snapshots of work in Rawhide, but for the most part, we're on a 6-month cycle with that, which is a little bit slow when you're talking about Docker and some of the other stuff. With CentOS, we are trying to pile stuff in pretty much and generate new images pretty much as quickly as we can. So we have, again, the QCOW images, the AMIs and stuff like that, and very soon now we should have Vagrant boxes and bare metal images for CentOS to use with Atomic. We're also talking to some of the other CentOS SIGs about possibly using Atomic for the RPM OS tree stuff to produce a mutable host for their stuff, like, for example, the Zen folks who push out the Zen for CentOS. If you're just running a node that's going to run VMs, you don't necessarily need to update the packages on it. So the immutable host concept may work well there. Any questions about that? Yes, sir.
How does immutable host interact with its security package?
The best thing to do is basically spin up a new host when the security update comes out. You can do, and I'll show how to do an Atomic update, but you can also, the best way to do it in a live environment with a large production environment would be simply to stand up the new hosts, move the workload over, and then shut the old ones down for a security update, rather than trying to update them on the fly. So that's kind of what Netflix has been doing now for a couple of years, and it's a pretty good system. So, I'm sorry? How do you mean? I'm sorry. So the question for the video, by the way, apologies that I forgot that earlier, is what is it using for version control? It's basically Colin's own special sauce. So it's not actually Git. It's fairly similar, but it's not using, Subversion or Git or whatever behind the scenes. So any other questions? Has anybody located a air conditioning unit yet? Anyway, all right. So this is all the contact information if you want to, read up or interact with Project Atomic. And now what I want to do is kind of a quick demo of actually doing the RPMOS tree update. And again, what I've been doing here, and this may break, let's hope not. What I did was, Jason Brooks, again, has written a tutorial on building your own atomic trees. So remember earlier when I was saying, we provide a minimal host. Now maybe there's something in your environment that you just desperately need. On the long-range roadmap for RPMOS tree, there is a concept of doing overlay packages where you could actually install something, but right now RPMOS tree does not allow you to install new packages. So how does that work? Basically, if you need a new package right now, you generate your own tree. So Jason's written up a really good tutorial on doing that, and so what I have done is basically taken Fedora 21 package set and added a couple of packages to the tree, and what I'm going to try to do is do a quick update from one that I built. I built it all inside of a privileged Docker container, because bad things happen when you're running RPMOS tree in an unprivileged container. It doesn't work so good. Any questions on that? Let me, this is the fun part of the presentation too, in which I try to type while looking at this screen over here. So my brain doesn't like that. Oh, wow. That is really washed out. Okay. What's that? Yeah, well, green, actually. Yeah, I cannot really see that. Okay. Yay! Okay, good. So this is running, this is the host updating itself, just for extra geek points. Basically, the Docker container is running on a Project Atomic host. And it's basically the build and all that happens inside the container. Then you start up an Apache server that points at the repository, and RPMOS tree looks at that repository. If it sees new stuff, it pulls it down and it does an update, which it's doing right now. And then if you look here, let me pull this over. I'm running Cockpit in my browser here. And so Cockpit is running both in the Atomic host and on my laptop. So the top one that says Lenovo there, which is suddenly becoming a bad word these days. Anyway, this was the pre-nastiness Lenovo laptop. So you can see it's running the VM that's running the Atomic host, and then you can see up at the top the CentOS Atomic. It's actually Fedora, but ignore that. Is also running in here. So you can actually drill down into these hosts and see what's going on in terms of memory and networking, storage, your user accounts. You can see what containers I have on my system. And by the way, this is an older snapshot of Cockpit that was basically stabled up for Fedora 21 release. The Cockpit team, Steph Walter and the rest of those folks, have been doing some phenomenally great work updating Cockpit and adding new features. So the current, this is like .27, and they're on like .39. So they've added a lot of features since this particular snapshot that's current with Fedora. With Fedora 22, you should see a lot more stuff, and even the ability to interact with Kubernetes and do a little bit of orchestration there. But you can do, you can drill straight down into a container and actually even log into the console of a container from Cockpit. You can get into, the journal and see what's been going on in the systemd journal. You can check out whatever warnings and errors you've been getting. I guess I don't have anything going farther back than that. You can drill down into your networking, all sorts of fun stuff. So this is a pretty handy little tool. If you're running, say 50 servers, it might be reasonable to use this instead of Kubernetes for orchestrating and managing servers. And they also ship this with Fedora Server. So, if you're running Fedora on the server, or later on, if you're running, say, CentOS on the server, you could be using Cockpit to manage those as well. So let's go ahead and go back to the VM here. We should be done. And what you can see here is we've removed a couple of packages from that build. And so all I have to do is run a system control reboot, and it will update into the next, into this update. That's another downside. That is one downside to RPMOS tree, but it plays into the immutable host concept, which is basically, it doesn't matter if you're updating the kernel or you're updating Vim, you have to reboot for the change to take effect, for it to switch to the new tree. All right, so we'll go ahead and do a reboot here. Now that probably looks a lot like Grub or whatever, but here you can pick between the extant trees. One of the really nifty things about this is you're not actually limited to doing Fedora on the box. I could actually have I could update from Fedora to CentOS and still keep my user data. I could go from Fedora Rawhide to Fedora 21. I could go from Fedora Rawhide theoretically to CentOS 7 and still have the same containers and still have the same data. Whether that's a smart thing to do or not, I will not give an opinion on, but you could do it. And you could actually have, and one of the things we hope to work out in the CentOS SIG pretty soon, is basically having a reference for both a stable stream of updates and a development stream of updates. So you can have, if you have a development box, you can follow the stable stream and then do an update and check out the development stream without having to do, dual boot systems and things like that. Any questions?
Yeah. How are those different snapshots or revisions stored on the disk as opposed to the
Basically, so RPMOS tree sees the tree a little bit differently than you see it when you're logged in as a user, and it keeps kind of an A-B tree on the disk. So it does take up some more disk space. So, yeah. So things like Etsy, Home, whatever, they're stored under a var directory that is not managed by it's not changed by RPMOS tree. With Etsy, when you have, if you make a change to a configuration file, it will actually try to do a merge with your updates. So you won't blow away, if you've changed configuration files, you won't blow them away when you do an RPMOS tree update. I'm sorry?
How does the merge work?
As far as I'm concerned, magic. But basically, it's a three-way merge, and the exact algorithm that's used, I couldn't explain easily. So.
Go back. You have to reverse all the version.
Yeah.
What does it do?
It's a good question. I have not Well, no, it does not. It's not going to store. So let's say I update, to be simple, let's say I update my Etsy Resolve to, add new name servers. And then I go back. It is not going to erase that data. It's going to assume that I want to keep the same configuration files that I had either way. It's not going to try to revert them to the previous state. Yeah, it should never overwrite that. What's that? It should not. When you're editing something, it's going to be aware of that change. So it's not tracking, it's not like Git in the sense that it's tracking your changes, So like if you delete a file in your home directory, it's gone. You're not going to be able to revert and get back to that. So it's not doing those sorts of snapshots. Does that kind of address what you were?
Yes, I'm more concerned about the configuration in Etsy. I suppose the upgrade somehow knows if there is some change to the server, for example, that the parameters updated accordingly to the version somehow.
Yeah. So anyway, as you can see, I've done the update here. You can actually do a so you can do a status, and it will show you which tree you're currently in. You can do, if you decide, okay, well, I screwed up and I want to go back to the previous version. So there, it just basically moved me back to the other tree and told me, okay, well, I'm going back to that, and here are the packages that you removed in this previous update. They're added again. So when you reboot, you'll have those packages again. Yes, sir.
If you roll back, can you then roll back again?
Yeah. No, you don't. It doesn't work that way. It keeps two trees right now. The way Colin, as I understand it, OS tree and RPM OS tree have the ability to do more in terms of like moving backward and forward in history, but right now it's only exposing those two updates. So you've just got an A/B system going on. Yeah.
So it's kind of like embedded systems where you'd have like two.
Right.
You'd go back to a working system.
Right.
So you could theoretically give it back but I've done that where it's updated a block for 2 years. I'm like, where'd all my this go?
Right. Yeah, so in theory, right now you can basically go back to the last known good system, or you can stay on the current. And when I do another update, it's going to get rid of the older one. So, or whatever I'm not currently in, basically. So, does that, yeah. Any other questions, comments, thoughts? Yes, sir.
Any high-level, key differences between Atomic and Core OS?
There are a number of differences, but anything in specific,
I know Kubernetes versus Fleet and etcd, but are there, because Core OS has similar, I don't know if it's actually using RPM OS tree or not.
No, I don't believe so, no.
You have a similar failover where
right.
But I wasn't sure if there's any other specific things that are benefits in Atomic that aren't in Core OS.
So I'll be honest and say that I have not really used Core OS a lot, so I can't enumerate, this is better here or there. There are a number of advantages to this approach, one of which is that, basically if you're already using RHEL or Linux in your data center, more than likely Core OS is sort of like a special snowflake in your environment. Whereas, if you're already managing something based on RPM, you probably want to manage other systems that look like that rather than something that's different. There's also the fact that, you're running the host, you also want something in the containers. It probably makes more sense to work with, an OS that actually has a solution for what you're putting in the container as well as what's running it, right? There are, different decisions being made about the orchestration layer and packages and things like that. But where it makes sense, we're adopting things from Core OS as well. So like the flannel stuff that they've done as far as networking, we've gone ahead and we're working on that. And I think probably trying to commit patches back to them. And we're also actually looking at, in the not too distant future, packaging Rocket as well, so that people have a choice. Dan Walsh is working on a tool called Atomic that basically adds some features and does some stuff that is not in native Docker, that eventually could be extended to work with, so you're using one command working with Docker or Rocket. So that thing would be seamless to whoever's working on it. So that would be another thing that kind of is a difference. Whether you consider an advantage or not is really up to you. The work that we're putting into SE Linux to secure containers and systemd, that's probably a bit of a wash, because I think CoreOS is taking a lot of the work that we're doing in those areas and putting it into CoreOS. So we're actually using etcd. Yeah. So whether or not we always use etcd is another question. And we too, at least especially in the CentOS SIG, there's flannel for networking, but there's also Weave. And I would be perfectly happy to see the folks that are behind Weave show up, and we could possibly do a spin based on using that for networking instead of flannel for people who want to try that out. So another, I guess, advantage is we have the room to experiment with a bunch of different stuff if people want to show up in the CentOS SIG or the Fedora work group and put some work into things. So, yeah.
So you mentioned flannel and Weave.
Yep.
Can you kind of describe what the features are that they have, or what the reasoning is?
Not in great detail, no. So sorry, I am not a networking guy on any level. So, yes, sir.
You mentioned something about supporting images in the container. Actually, what is Atomic planning to do with this?
I'm sorry?
You mentioned earlier that Atomic is not only about the host,
Right.
like a Docker carrier, but also for the images that go through Docker, right?
Oh, okay. So the question is, what is the Atomic plan for what's in the container? So, I mean, basically, that's what I'm talking about. Atomic there, for example, if you're running the Fedora 21 Atomic host, you probably want to be running Fedora 21 in the containers as well, or CentOS, or something that looks like that. We're not going to produce like a special Atomic container image or anything like that, but we are working with CentOS and Fedora to produce a set of kind of a library of images. Like if you go to the CentOS Docker part of the Docker Hub, you'll see that we have like an Nginx and a Wildfly and a couple other containers based on CentOS, which get updated pretty regularly as soon as CentOS gets updated. So, what time is it? Because I want to make sure I'm not stepping on. I have about time for one more question. Or no more questions if no one has one. Yeah.
You're going to go on and talk about spinning a tree. If you want to add additional packages,
Yeah.
are you going to talk about that?
Sure. It would take a little bit too long to actually run this, but I'll show you all you would need to do. All right. Okay, that's not where I wanted my mouse. Come on. Well, let's see here. All right. Yeah. There we go. Let's see. Darn it. Oh, that's special. Apologize, I can't really see where my cursor is at on the other screen, which makes it really hard to actually, there we go. Ah. All right. All right, so basically to add packages, there are two steps. One is you edit this JSON file. And basically all you would do is put the packages in this section here where you want to add packages or remove a package if you don't want it in there. And then basically you're going to run one command, an RPMOS tree command, that is going to generate a new repository, and it will do, you know, basically the whole fetching all of the packages and putting them together and spinning it up into a tree. And that's it. That's all the steps that are required. And then you would do an update from that. One other thing you would need to do is go ahead and edit the configuration file that points at the repository, and that's it. Yeah. So that's it. Basically, all I had to do there is change the URL. Right. Yeah. And they come with a reference to, you know, and you can actually add other remotes, and there are additional food that you can do to actually switch between remotes and some things like that. So we have that stuff on the excuse me. We have that stuff on the Atomic website. So all right, well, I am pretty much out of time, so I thank everybody for their attention, and good luck. You don't want to leave now, because Jim is going to discuss doing some really horrible things with containers. But they'll be entertaining.